So I saved that towards the end. Let's go over data budget and profiling. So just like the power budget and the mass budget, data is a finite resource, and you do have to think about how to budget it throughout the mission. The way to do that is to first define the subsystem components: throughput, CPU utilization, memory needs, update frequency, and required timing synchronization. Summarize the computer characteristics for each mode by summing the individual characteristics of each component in each mode and determine which mode will drive the computer design. So we haven't gone through this table before, but for all of the different modes, different components are going to be on and off. Depending on which of those components dominate that mode, these different computer characteristics are low, medium, or high. Really, what we want to see are update frequency and throughput estimation. Update frequency is how frequently you'll be sampling data, and throughput is going to be the data rate. How much data is going to be coming through with every update. And that will give you this chart over here where you summarize. So we're summarizing computer characteristics for each mode. Each mode is on a column. Each component is then specified about how much data is coming through. Here you'll see at the very bottom, the most intensive mode is data collect mode, of course. So that has your highest data rate. Then you can take your mode of operation profile. So for an orbit of 90 minutes, we have this sequence of modes where the different modes are associated with amount of data generated. And you want to integrate the amount of data generated onto how much available space is on the mass storage. So at the beginning of mission, the Artemis CubeSat kit has 12 megabytes. But as you see, as we're just nominally operating, as we are eating away at the available space on the mass storage. But once we transmit data, then we regain some of that space. Back to nominal operations, we are accumulating. So this should give you the information necessary to size the mass storage that you need on the spacecraft. But it also gives you information as to how frequently you need to transmit and how much data you need to push through when you do transmit. From this analysis, at the very end, we see that the mass storage over the orbit returns back to original levels, verifying that the mission is sufficiently supported by the mass storage system. If the mass storage slowly fills up every orbit, then you're going to have to figure out or find a larger mass storage system. Or you can modify your mission operations to spend longer periods in downlink, or your communications specialist can find a radio that is more capable of downlinking data. You can also use this analysis to say that we actually have too much mass storage, and we can save on physical mass, kilograms, if we size a smaller mass storage. Based on our basic payload and radio, the Artemis CubeSat needs at least 8 megabytes of dedicated mass storage in order to avoid running negative over time.